Okay, we are now going to do the second part of the first lesson of unit circle trigonometry, and we are going to work specifically with our trig functions. So in the past, you've done SOHCAHTOA for your right triangle trigonometry, and the same thing can work here. So our angle that we're working from is always this angle here. Remember, it always comes from the horizontal axis. And so if we are looking for sine, that is opposite over hypotenuse, which is y over 1, which we can simplify to y. Same thing with cosine, adjacent over hypotenuse is x over 1, which we can simplify to x. And the way I remember that is if I'm given an ordered pair, and it's x comma y, well, that's going to be cosine comma sine, or in my head, I just say cosine to remember that cosine comes first because it wouldn't be sine co. That's not a trig function. So cosine, and that's the order it goes in your ordered pairs. Tangent is opposite over adjacent, so y over x. And that is the same as y over x, change in y over change in x, which you'll remember is your slope formula. So the tangent is the slope of the hypotenuse. Just like sine is how far your x goes, cosine is the distance of your y, and then so that's how it relates. And that's how you can kind of see it on your unit circle to double check you. These are new functions. These three are your reciprocal functions, and they're simply that. They're reciprocals. And so if you can remember the first three, then you can just invert them for your new functions. So cosecant is the reciprocal of sine. So it's instead of y over 1, it's 1 over y, or 1 over sine. Secant is the reciprocal of cosine. So instead of 1 over x, it's 1 over cosine. And then cotangent is the reciprocal of tangent. So x over y, or 1 over tangent. And that is actually as well how you will input them into your calculator if you needed to, which you won't be doing that a lot, but you can do it to check. Now we're going to be evaluating our 6. We only have 3 here, but we're going to add in and do all 6 trig functions for our first quadrant. So hopefully you have these memorized. If you need to use your unit circle, you can. But at 0, so we're in radians here. For 0 radians, our coordinate is 1, 0. And if you remember, it's cosine. So cosine is our x, sine is our y, and tangent is y over x. So my y is 0, my cosine is 1, my tangent is y over x, 0 over 1, or 0. And if you look at your unit circle, for this line right here, there is no it is the hypotenuse itself. And so we want to know what the slope is, right? Remember, that's what tangent is. And the slope of a horizontal line is 0. And so that's why that makes sense. If we go on and add our other 3 trig functions, we have cosecant, which let's write these up here. This is represented like this. And we'll evaluate these. Sorry. Here we are using angle T. So we're going to evaluate these 3 as well. How I remember it are the C's and S's are reciprocals, because cotangent and tangent are easy to remember. But secant and cosine, sine, and cosecant. So a C always goes with an S, but it's not the ones that sound alike. So for us to finish off the other 3 trig functions for 0, for cosecant, we need to do 1 over y, or you can just do the reciprocal of sine. And so right now we have sine is 0, and so we want the reciprocal of that, so we're going to stick a 1 over it, and 0 on bottom means it is undefined. Secant is the reciprocal of cosine, so 1 over 1 or 1. Cotangent is the reciprocal of tangent. Tangent was 0. And so again, you have 1 over 0, which is undefined. Now let's do another. Pi over 6 is the square root of 3 over 2. A different color, 1/2. So it's always easiest to start with your sine and cosine, of course. And so we have our x and our y. And then for tangent, our y over x, and might need some room to kind of do some work here. So y over x. Instead of dividing by a fraction, we're going to multiply by the reciprocal. And we get 1 over the square root of 3. But you know we can't leave it like that because we can't have a radical in the bottom, so we have to rationalize by multiplying the numerator and denominator by the square root of 3. So the tangent of pi over 6 is the square root of 3 over 3. And of course, you're going to be dealing with the square root of 3 over 2 and 1/2 in some form, right? It might be vice versa. You're going to be dealing with those a lot, and so you'll get very used to this process. So cosecant is the reciprocal of sine. So I'm going to flip 1/2. You know that's 2. Secant, we're going to flip square root of 3 over 2. But yet again, not okay. We have to rationalize. And we get 2 square roots of 3 over 3. And we can't reduce that. Okay? And then we have to flip our 3 over radical 3, which again is going to be is going to have a radical in the bottom, and we have to rationalize. So you can actually go back here, right? This was the tangent. We just rationalized, but if I flip that, I get the square root of 3 over 1, or just the square root of 3. Now let's do pi over 4. So if you remember from your unit circle, pi over 4 is the square root of 2 over 2, square root of 2 over 2. So that makes our cosine and sine very easy for us. What happens when I put the square root of 2 over 2 over the square root of 2 over 2? Now you can do it by hand. And we're going to do the same thing that we did before. Instead of dividing by a fraction, you multiply by the reciprocal. But we shouldn't need to do that. We should realize that if we have the same thing we're dividing by as the numerator and denominator, that it just simplifies. And the nice thing is, let's go ahead and skip here. If we put 1 over 1, we get 1. Now we need to find the cosecant, which is the reciprocal of sine, but since sine and cosine are the same, cosecant and secant are also going to be the same. So I want to find the reciprocal of the square root of 2 over 2, which is going to be 2 over the square root of 2, and then we'll rationalize. So we get 2 square roots of 2 over 2, and so for both of these, the square root of 2 is our answer for secant and cosecant of pi over 4. Now I want you to pause it, and I want you to find all 6 trig functions for pi over 3 and pi over 2, and then check back. Okay, so hopefully you worked those 2 out, got the same thing. You probably did several things that felt very familiar to you from the ones above. Pi over 3 and pi over 6, that swapped. So since sine and cosine are opposites, cosine and secant are also opposites, like those were reversed. And the tangent of one's the cotangent of the other, and vice versa. Same with 0 and pi over 2. X and y just swapped, so sine and cosine swapped, which meant cosecant and secant swapped, and then cotangent and tangent of one and the other swapped as well. So you should be able to calculate all 6 trig functions for any coordinate, but especially in the unit circle, as long as you know your coordinate, then you have your sine and cosine, and then you can calculate all 6. Even if I gave you something that you didn't know, so say I made something up, this doesn't have to be on the unit circle. So to give you something like that, you could still calculate sine and cosine, tangent, secant, cosecant, and cotangent, all just by knowing your x, y, y over x, and your reciprocal functions. And to help with that, though, there is a mnemonic device we use for your trig functions. All students take calculus. And of course, if we're dealing with a coordinate plane, we go in the order that the quadrants go in. So all students take calculus. And what this is for is this is for what is positive. Okay, so these are the positive values for not just unit circle, but anything that falls into these quadrants. So all of them are positive here. Sine, cosine, and tangent, those are the three we're actually going to work with, sine, cosine, and tangent. And then if it's a trig function is positive, its reciprocal is as well. So in the first quadrant, both x and y are positive, and so y over x is also positive. So sine, cosine, and tangent are all positive in the first quadrant, and since those three are, they're reciprocals as well. In the second quadrant, it's a negative positive, so cosine's a negative, sine's positive, so S, all students, S is positive, sine's positive, and because one of each is positive, then when you divide, you get a negative, so tangent isn't either. But here, sine and cosine are negative, but a negative over a negative for tangent is positive. So in the third quadrant, tangent is positive. And then in the fourth quadrant, cosine is positive and sine is negative. So that kind of helps, like if we're asking for maybe the cosine or any trig function of something in a different quadrant. So let's say we want to know all 6 trig values for 5 pi over 3. Well, you can use the coordinate for this, which you should know, and you can calculate all 6. Or you can say 5 pi over 3 is the same as pi over 3. It's going to have all 6 of these, with the exception of this is in the fourth quadrant. So the only thing that is going to be positive is cosine, and its reciprocal. So that means it would be square root of 3 over 2, but that would be negative because that's sine. 1/2 square root of 3 would be negative, and you can use this to help you, or you can just calculate all 6, either way. So if you know these 6 things, you should be able to calculate any and all 6 trig functions for anything on the unit circle because you have it memorized and anything else you were given.